Before we move on, I want to talk about two more classes in the collections framework, specifically created to support enum types more efficiently. You can use any list, set or map with an enum constant. The enum set and enum map each have a special implementation that differs from the hash set or hash map. These implementations make these two types extremely compact and efficient. There's no special list implementation for enum types. The enum set is a specialized set implementation for use with enum values. All of the elements in an enum set must come from a single enum type. The enum set is abstract, meaning we can't instantiate it directly. It comes with many factory methods to create instances. In general, this set has much better performance than using a hash set with an enum type. Bulk operations, such as contains all and retain all, should run very quickly in constant time, big O of 1, if they're run on an enum set, and their argument is an enum set. The enum map is a specialized map implementation for use with enum type keys. The keys must all come from the same enum type, and they're ordered naturally by the ordinal value of the enum constants. This map has the same functionality as a hash map with O1 for basic operations. The enum key type is specified during construction of the enum map, either explicitly by passing the key types class or implicitly by passing another enum set. In general, this map has better performance than using a hash map with an enum type. Let's review some of the things you can do when you combine enums with these collections. I've created a new project called enum collections for this video. I'm going to create an enum type in this class called weekday. This enum will contain all the days in the week. Let's say I'm interested in assigning work days to different employees. I already have an employee named Anne, so I'll set up a list of the days she works. The list type will be the enum type weekday. I'll call the variable Anne's work days, and that will be a new array list created using the list.of method with Monday, Tuesday, Thursday and Friday. I'm going to use Anne's work days to figure out what kind of coverage I'll need for other employees I want to hire. First, I'll use one of the creational methods, a factory method, on the enum set to create a set of Anne's work days. By the way, a creational method is one that is responsible for creating and returning an instance of an object, typically through a static factory method, constructor or other means. So it's a generic term for a factory method that creates and returns instances of an object. I'll call enumSet.copyOf and save this into a variable called Anne's dayset. This method will take any collection type. I then print out the actual type of the instance I get back. Before I run it, notice that the inferred type is an enum set with the type of weekday. The enum set is an abstract class, as I mentioned on the slide, so if I want to know what the set type really is, I'll need to run this code. Running it now. You can see my instance is a regular enum set. Okay, so what is that exactly? Enum sets are represented internally as bit vectors, which are just a series of ones and zeros. O1 indicates that the enum constant with an ordinal value that is equal to the index of the bit is in the set. A 0 indicates the enum constant is not in the set. Using a bit vector allows all set operations to use bit math, which makes it very fast. A regular enum set uses a single long as its bit vector, which means it can contain a maximum of 64 bits, representing 64 enum values. A jumbo enum set gets returned if you have more than 64 enums. This slide is a visual representation of the enum set for Anne's workdays. Its size is 7 for the 7 possible values based on the number of constants in the weekday enum. Any weekday that's part of her set will be set to 1 at the index that corresponds to the weekday ordinal value. Monday has an ordinal value of 1 in our weekday's enum, and the value in the underlying bit vector at position 1 is a 1. This means Monday is part of Anne's enum set. Okay, so let's get back to the code and explore this class a little more. I'll print Anne's day set out, each day on its own line. As you can see, Anne's workdays are printed out in the order defined in the enum. This is another advantage of using just a hash set with an enum type because the set is naturally ordered by the ordinal value. We can create a set for all the enum values using another factory method, all of. I'll set up a local variable, again using var, named allDaysSet, and assign that enumSet.allOf, passing that weekday.class as the argument. I'll print a separator line for clarity, then I'll print each element. Running that now. It just prints out all the days in the enum in order. You might be wondering why that's useful, since that's data we can just get using enum's values methods. Hold that thought for a minute. First, I want to show you another method called complement of. I'll set up a set of weekday this time, calling it new person days. I'll assign that the result of enumSet's static method complement of and passing it ansDaysSet. Again, I'll output a separator line and print what that gives me. Running this now. I get Sunday, Wednesday, and Saturday. So what did this really do? What set math operation is this? If you study this for a moment, you will realise that this is a difference of the full set of all possible workdays minus ansSet. I can get the same results with the remove all bulk function, which I'll do next. I'll make a copy of the full set and call it another way. I'll call the remove all method on that, passing it ansDaysSet, and I'll print this set out. Let's check the output. You can see I get the same result. It was a lot easier to use the complement of method. I didn't have to create a set of all elements or call the remove all method. One other creational method is the range method. I'll set up a new variable called business days. I'll set that to the result of enumSet.range, passing it Monday and Friday. I'll print those out. You can get all the days between Monday and Friday, including both Monday and Friday. All other operations on this set are the same as those I covered with the hash set, so I won't go through them here. Moving on, let's now look at the enummap. This class is not abstract, so I can create an instance of it directly using new, but unlike other map implementations, it doesn't have a noargs constructor. I'll create a map, keyed by weekday, and each mapped element will be an array of string. That array will be the names of my employees who work those days. I'll assign that a new enummap instance and pass it weekday.class. Now I have an empty enummap. I can add elements in the usual way with put all, put if absent, compute if present, replace all, and the other many methods of a map. I will just use the put method here. I'll add Friday's crew Anne, Mary and Bob. I'll next add Monday's crew Mary and Bob, and then print this data out. Notice here that these are again ordered by weekday without me having to use a sorted map. I also didn't have to insert them in order, like I would have to do if I had used a linked hash map. Again, I won't cover all the methods I've covered previously with the hash map. This class has all those methods and works very similarly to a hash map with a key type that's an enum, but it's more efficient and it's naturally ordered. This lecture ends the material for the collections framework section of the course. We covered a lot of ground. Before I start a new section, I do want to give you one last opportunity, a challenge that will give you a little extra time with some of these concepts. I will see you in that next video.